High-speed centrifuges converting heat to electricity. Use the principle of threshing by farmers in ancient times to understand the principle of centrifugal force converting heat energy into electrical energy. This explanation is based on a concept proposed by C.F.to.E.e. Chen on April 29, 2022, reference point 1. The principle involves using the separation of positive and negative ions under gravitational or centrifugal forces to generate electric fields and electricity. Example 1. Separating uranium-238 and uranium-235. In nuclear fuel production, centrifuges are used to separate uranium isotopes with a slight mass difference, uranium-238 and uranium-235. When a centrifuge spins at high speed, the heavier uranium-238 is pushed outward due to stronger centrifugal forces, while the lighter uranium-235 remains closer to the center. Applying this principle to potassium fluoride ionic solutions, heavier potassium ions, K, behave like uranium-238, moving toward the outer layer, while lighter fluoride ions, F, gather near the center. This uneven distribution of ions creates an electric field, which can be harnessed through electrodes to generate electricity. Example 2. Farmers separating rice and husks. During the threshing process, traditional farmers separate rice grains from husks by shaking a container, using gravity and motion to sort heavier grains to the bottom and lighter husks to the top. In this analogy, potassium ions are like rice grains, and fluoride ions are like husks, while the shaking motion represents molecular vibrations driven by heat. Just as the energy from shaking separates rice and husks under gravity, heat-induced molecular vibrations can separate positive and negative ions under centrifugal or gravitational forces. This separation of ions generates an electric field, enabling electricity to be produced. From heat to electricity. These examples demonstrate how differences in ion mass allow separation under centrifugal or gravitational forces, generating an electric field. By placing electrodes in the solution and connecting a circuit, this electric field can be converted into a stable electrical output. Heat serves as the source of molecular vibrations that drive ion separation, making it possible to transform thermal energy into electrical energy. If you still have questions about the principle, you can refer to the original article written by C.F.to.E.e. Chen on April 29, 2022. This concept, proposed by C.F.to.E.e. Chen, opens new possibilities for future energy conversion technologies.